Okay, I'm making this video as some feedback on how to solve this mastery check. Now, there's a few different ways that you could do this. I'm going to show you the way that I did and draw your attention to some different things that I saw that worked or didn't work when I was grading these. So, for my prepare, I went ahead and drew a picture of the cross section that we have here. So I have a width and a length. You can use any variable you want. And then I put together some formulas that I knew already, right? So my perimeter in reference to my picture is going to be 2 times length plus 2 times width. And then my area is length times width. And then I wrote down a couple things that I need to know and figure out here, right? So the area must be 1,800 square feet and the perimeter must be less than 200 feet. Okay, so hopefully you see that this is going to be a range of numbers, right? If you really understand what's going on here, there is a range of widths that will create a perimeter that's less than 200 linear feet. And we can see that in the problem right here, no more than 200 feet. So we're not just looking for one width here. And it says, there's a typo here. It should say widths and lengths. If you just found the width, that's fine, or just found the length, that's fine. But we'll talk about that at the end. One thing that I saw as far as the prepare that I thought was clever was someone found the factors, or a couple of people found the factors of 1,800, right? Because those would be our possible length and widths. So while that can't give us our exact answer, because if you don't include all the fractional possibilities for length and width, then you're not going to come up with all the possible values, but it kind of gives you a guide, right? So you're showing that you really understand what this problem is made up of and how to get to the end. And maybe you don't use those numbers in your answer, but you're using them to reassure you that your answer is correct. So now we're going to solve. Well, actually, before I do that, I want to set up an equation, right? So I need to define my variables. So I have L as length. I have W as width. I have, this is my area. And of course my perimeter. And now I'm going to come up with one equation. Now the strategy I used was to come up with an equation with perimeter in terms of width. Right? So looking at my variables, I'm going to get this in terms of this. And the way to do that is I'm first going to isolate, right? I'll take my equation here, perimeter. In terms of width, well, what that means is I need to get this L out of there, right? I don't want the L, I want just W. So I can use my other equation to come up with length in terms of width. If I do that, then I can just plug it into my original, right? So we did stuff like this in Unit 1. So I'm going to take my area, which I know has to be 1,800. And I'm going to isolate the length, so that way I have length in terms of width, right? So by isolating the length, I'm going to divide by W. So I have L equals 1,800 divided by W. Okay, so now I'm going to take all of this and plug it into my perimeter formula. So my perimeter is 2 times 1,800 divided by W plus 2W. Okay, so now I've accomplished this. I've got my perimeter in terms of width. Okay, so how am I going to use this equation? Okay, well, I want a width that creates a perimeter that is less than 200. Okay, so I'm going to say 200 so as I plug in different numbers for width, right, I want it to always be less than or equal to 200. Now from this point, I can solve it a variety of ways. One of the ways is I can just graph it, right? So if I graph it, you're going to end up with something that looks a little bit like this, okay? And then I have to label my axes correctly, with this being the width and this being the perimeter. And then I'm going to graph another line at 200, so y equals 200. And I have some intersections here. This graph doesn't look exactly like that, but it mostly looks like that. It doesn't cross the x-axis at all. And this intersection, I'm going to say, is approximately 23.576. And this point here is approximately 76.235. So now it is all these widths, all these values for these widths, that keeps my perimeter under 200. Okay, so then in my learn, I would write some sort of sentence explaining how in my graph I saw that it's the values from 23.576 all the way to 76.235 that provide a perimeter that is less than 200. Some ways to ensure that you are proficient at this is to refer back to how you found these values on your graph, why it makes sense. Ways you could extend on this is maybe try a point, right? Not just these points, because that's exactly where it is 200, which the reason I say not these points is because a lot of people, when they made a mistake, just found these points and called it the length and the width, which we'll talk about in just a moment. But I know that there's a point here because I've looked at the graph. That's 30 and 180. So what does this mean, this 30 and 180? Well, the 30 is the width, and the 180 is the perimeter, right? So 180 is definitely less than 200, right? So now what would be the length that goes with that? Well, 30 times length equals the area, which is 1800. If I were to solve this, I would come up with 60, and then I can check that 2 times 60 plus 2 times 30 does in fact give me a perimeter of 180. Okay, and then I could also check a point that's outside of this and see if it's too much, because that's what should happen. It should be too much. All right, here's another way that I saw people solve this. And this would have been fine, except that they didn't interpret what they found correctly. So they just took their equations just as they were and graphed and found the intersection of those equations. So it's not that the equations were incorrect, but they misinterpreted how to use them or the graph. So they said that the area has to be 1800, and that's equal to x times y. And then that the perimeter had to be less than 200. Right, so they had 200, and the perimeter had to be less than that, so 2 times x plus 2 times y. Okay, and so then when they did their graph, over here, if you look at my graph, I have perimeter in terms of width. Depending on how they set it up, they might have had x equals width and y equals length. Either way is fine. And so then they might have isolated one of their variables, which when we have x and y, we usually isolate the y. So we would have 1800. And then they would do the same for their other equation. So 200 minus 2x, 2y, then divide by 2. There we go. Okay, so they had a couple equations like this. So then they graphed it, and they were able to say that they have their length and they have their width here. Okay, and it's not that these equations are wrong or couldn't have been used like this, but then they misinterpreted it, and they got the same intersections as we did before, but they said it's this length and this width that creates all of the perimeters below 200. And that's not true, because it's a range of perimeters. So really what's going on here is when I graph this equation, which is this one right here, right? Then if I were to shade this in, what are all these points, right? To graph a linear inequality correctly, really you're shading in all of this. So what are all of these points that I just shaded in red? Well, these are all points that give me a length and width that create a perimeter less than 1800, right? Those are all these points in red. Now it is all these specific points that are in that area but fall specifically on this line that also give me an area that's 1800, right? That's what this equation is. Okay. So your method for solving can be different from other people's method from solving. But you do have to come up with the right answer or interpret your graph correctly. And I think that's what went wrong for many people who graphed it like this. But there were definitely some who graphed the two equations and still were able to understand what was going on here. So maybe if you have a systems equation, get it down to one equation, right? And then you can just graph what it's equal to, and then you can visually see it below the line there.